What's up, ComSci community? So this semester I'm taking object-oriented programming for one of my classes, and the book that we're using is Starting Out with Python. So I thought that I would go through chapter by chapter and solve the programming exercises, and today I'm just going to do chapter 2. So I'm going to walk through problems 1 through 12 really quickly, and I'm going to show you exactly how they're done. So these are the 12 different programming exercises in Chapter 2 of Starting Out with Python. So I'm just going to go through them all one by one. They only take a couple minutes each, so it's not going to take very long. And we're going to start with this first one, personal information. So this is really simple. It just wants you to write a program that displays the following information: your name, your address, your telephone number, and your college major. You could do this really simply just by adding some print statements that accomplish this, but this section, they want you to use variables, even though they don't say explicitly. So the first thing we're going to do is just add these variables. So there's one variable called name, and I gave it a value of Tim. There's a variable of address, and I gave it this value of a random address. That's not my actual address, so don't come searching for me. I made a variable called number. That's, again, not my actual number. Don't try and call it. And my major, which actually is computer science. So the next thing that we want to do is create some print statements that utilize these variables. So now we have these 4 print statements. My name is plus name, my address is plus address, my phone number is plus number, and my college major is plus major. So let's go ahead and run this and make sure that it works well. And it does. It functions exactly how we would expect it to. So that's it for program number 1. Let's move on to program number 2. A company's annual profit is 23% of total sales. Write a program that asks the user for the total sales, then displays the profit. So the first thing that we want to do is make a constant variable. And with constant variables, you want to make them all caps. That's just kind of like a standard practice. And variables that aren't constant, you can leave them lowercase. So the next thing that we want to do is make a variable called sales and ask the user how much was the total sales. And we do that with this input function, but we also want to wrap it in a float function. This way the computer knows that this variable of sales, whatever is saved in here, whatever amount, is going to be saved as a float type instead of like a string type or some other type. The next thing that we want to do is make a variable called profit, and we want to make profit equal to whatever this variable of sales is, and then we want to multiply it by the profit percent. So what that's going to end up being is if somebody inputs 10,000 for the sales, it's going to multiply it by this 0.23, and that's going to be the actual profit. And lastly, we have a print statement here that says the total profit is plus profit, and the profit is wrapped in a format modifier. And what it does is it has this comma here that puts a comma if there's anything above 1,000. So 1,000 would be written like this, 10,000 like this, and then this 0.2f means 0.2 float, and the 0.2 means if there are any decimals, then it'll only go up to 2 spaces. So $10,000 would be read like this. Okay, now let's save this and run it and make sure it works correctly. What is the total sales? Let's give it 10,000. The total profit was $2,300. And of course, as I said, it has this distinct format. Okay, so number 2 is good to go. Let's open up number 3. One acre of land is 43,560 feet. Write a program that asks the user to enter the total square feet of a tract of land and then converts it into acres. So the first thing that we want to do is make a constant variable called 1 acre and give it a value of 43,560. Then we want to make another variable called square feet, and we want to use that to ask the user for an input of how much square feet is the land. We also again want to wrap it in a float function just so that the computer knows that this is a type of float. The next thing we want to do is make a variable called land, and we want to make this equal to square feet, which we ask the user for that sort of input. And then we want to divide it by 1 acre. And lastly, we're just going to use this print statement. We're going to say that is equal to, we're going to input land and then acres. So that is equal to so many land in acres. And again, we're going to format in the same way we did last time. Now this, you can see we're not using normal concatenation here. These commas actually add a space in between these values, so we don't need to add a space here and here like we would if we were doing normal concatenation. Now let's save this and run it and make sure it works correctly. How many square feet is the land? Let's say 100,000. So this should give us a little bit more than 2 acres. So as we can see, all our math is correct and the program functions how we expect it to. Exercise number 4 says, a customer in a store is purchasing 5 items. Write a program that asks the user to enter the price of each item and then displays the subtotal of the sale, the amount of total tax, and the total. The sales tax is 7%. So the first thing that we want to do is make a constant variable called sales tax, and we're going to make that equal to 0.07 to represent a 7% sales tax. And the next thing that we're going to do is we're going to create 5 variables to represent the 5 different items, and we're going to obviously ask the user for input for the price for each of these items. And again, we're also going to wrap this in a float because the price for the item could be it could be an integer like just $147, but it also could have some sort of cents in addition to the dollars. So we're going to make that a float. The next thing that we're going to do is a little bit of processing. We're going to make a variable called subtotal, and it's going to be equal to all the items combined. So item 1 plus item 2 plus 3 plus 4 plus 5. And again, we're going to wrap this into a float type. We're going to make another variable called total tax, which is just going to be equal to subtotal, which is the variable we just made of all the items put together. But we're going to multiply it by sales tax that we have set here of 7%. And finally, we're going to have the total, which is just equal to the subtotal plus the total tax. And finally, we're going to print all this information back to the user. We're going to add one blank print statement just to give us a line. The first thing that we're going to print is the subtotal is plus subtotal, and it's going to be formatted in this special way, followed by the total tax is plus total tax, and the total amount due is, and followed by total. So let's save this and run it, make sure it works how we expect it to. The price for item 1, let's say $1,000, 100, 200, 150, and 10. Okay, so we have the subtotal is $1,460, which is just a total of all this. The total tax is $102.20, and the total amount due, which is a combination of both of these, and that's $1,562.20. But if you're in my object-oriented programming class, we're actually not done. Our professor asked us to modify this program a little bit. So what we're actually going to do is we're going to make 2 more items. So this is really simple. We just copy and paste these last 2 lines. We're going to modify them to say item 6 and item 7. Going to modify the actual print statement, 6 and 7. We're going to modify the subtotal to include these items. Actually, I'm just looking back at my notes now, and it looks like the professor wanted 8 items, so we're going to add just 1 more. So this line was running a little bit long, and so instead of having it extend over here, what you can actually do in Python is just put this backslash key and press enter, and it puts it on a new line. But you know that the program knows that it's still part of the same line. Like this is all part of this subtotal. So now that we have these 8 items, the next thing that the professor wanted us to do is just change the total sales tax from 7% to 8.5. So now we're actually all done with this. What I want to do is just save it and run it again, make sure it works. Let's do the same numbers we had previously: 1,000, 100, 200, 150, 10, and now we get to choose 3 more. So let's just choose 150, 250, and 100. The subtotal is 1,960. Total sales tax is 166.60 cents. And then again we have the total. Oh, you know what? I just realized I have a typo here. I need to change this to item 8. Resave that. And now it looks like the program is actually finished. So I'm going to go ahead and move to number 5. Number 5 says the distance a car travels is measured by the formula distance equals speed times time. So assuming a car is traveling at 70 miles per hour, write a program that displays the following: the distance the car traveled after 6 hours, the distance it traveled after 10 hours, and after 15 hours. So this is simple enough. The first thing that we're going to do is make a constant variable called speed and make it equal to 70, because that's how fast we're actually traveling. So let's make a variable called time, make it equal to 6, because that's the first distance that we're traveling. It's going to be 6 hours. And now we have our distance formula. Distance equals speed times time. And now we can print to the user the car traveled distance miles after time hours. So let's actually real quick just save this and run it and make sure that this is working fine so far. The car traveled 420 miles after 6 hours. So it seems like it's working correctly. But we still have to add these other distances. So we want to do actually the exact same thing that we did here. So what we can do is we can just copy this and paste it one more time. We'll make this one equal to 10 and this one equal to 15. So now by the time the program prints this out and gets to here, now we've set time to a different value. Now time is equal to 10, and this distance variable is also changed because time has changed. Now we create this new formula. So now it accounts for a different distance, and same thing happens down here when we change time to 15. Now this formula has changed. So let's just go ahead and save this and run it and make sure that everything that I'm saying is actually true. Okay. The car traveled 420 miles after 6 hours, 700 miles after 10 hours, and 1,050 miles after 15 hours. So everything's working good. And let's move on to the next one. Program 6 is called sales tax. It says, write a program that asks the user to enter any purchase amount. The program should then compute the state and county tax. Assume the state tax is 5% and the county tax is 2.5%. The program should display the amount of the purchase, the state sales tax, the total sales tax, and the total of the sale. The first thing that we want to do is make these constant variables, and then we want to ask the user what the actual purchase amount was, and we're going to bring this into a variable called purchase amount. And again, we're going to wrap it in a float function, and we're going to make it a type float. Now we have enough information to actually do some calculations. So we can make a variable called total state tax, and we're going to make this equal to the state tax variable here times the purchase amount. And now we're going to make a variable called total tax, which is going to be the county tax here times the purchase amount, just like we did here with the state tax, but now we're doing county tax. and then we're going to add it to the total state tax, which we had right here. So this is going to be a combination of these two different taxes. And then we're going to have the final total here, which is going to be the original purchase amount plus the total tax. So now we can set up our print statements and deliver this information to the user. This is just a blank print statement to separate this from this. You'll see that when we actually run the function. So we have a print statement with the purchase amount is, followed by the purchase amount, the state tax is, followed by the total state tax, the total sales tax is, followed by the total sales tax, and the grand total is, and followed by the grand total. So let's save this and run it, make sure it works well. What is the purchase amount? Let's say $500,000. And we have the purchase amount is, just as we said, $500,000, and it's formatted to look like actual dollars. The state sales tax is $25,000. The total sales tax is $37,500, and we have the grand total is $537,500. So this program is complete, and we can move on to the next one. Program 7 is called miles per gallon, and it says a car's miles per gallon MPG can be calculated with the following formula. MPG equals miles driven divided by gallons of gas used. So now we have to write a program that asks the user for the number of miles driven and the gallons of gas used, and then it's going to calculate the car's MPG and display the result. So the first thing that we have to do is ask the user how many miles they've driven and how many gallons of gas that they used. And we're going to save these in variables that obviously represent this type of data that's stored in it. Miles driven and gallons used. The next thing that we can do is we can already process how many miles per gallon just by dividing the miles driven by the gallons used. And now it's really easy to display this information back to the user. We're going to use a print statement just to separate this from this, and another print statement to say that your average MPG is, and we're going to display the miles per gallon variable. So let's go ahead and save this and run it. How many miles have we driven? Let's say 200. How many gallons of gas were used? Let's say 15. So our average MPG is 13.33. So number 7 is finished. Let's close this and move on to the next one. Program number 8 is called tip tax total, and it says write a program that calculates the total amount of a meal purchased at a restaurant. The program should ask the user to enter the charge for the food and then calculate the amount of an 18% tip and 7% sales tax and display each of these amounts and the total. So the first thing that we want to do is create some constant variables. We're going to create a tip percent, which we're going to tip 18%, as well as a tax percent, and that's going to be 7%. The next thing that we're going to do is we're going to make a variable called sales price, and we're going to ask the user how much was the meal, and again that's going to be wrapped in a float. Now we can start doing some figuring. We're going to make a variable called tip, and tip is going to be the sales price times the tip percent. We're going to make another variable called tax, and tax is going to be the sales price times the tax percent. And then we're going to have the total, which is going to be the sales price plus the tip plus the tax. And finally, we can print this information back to the user. The first thing that we do is say the tax of 7% is, followed by tax in this format, and the tip of 18% is, and then we have the tip, and then the total with tip and tax is, and then we have the total all wrapped in this nice format. Let's go ahead and save this, and let's run it. How much was our meal? Let's just say $100. And we have the tax of 7% is $7, the tip of 18% is $8, and the total with tip and tax is $125. So this functions exactly how we want it to. But again, if you're in my object-oriented programming class, this is one of the other exercises that we were supposed to do for our homework, and the professor asked us to modify it just a little bit. So I'm going to do that real quick. The first thing that he asked us to do is change the tip amount to 18.75%. So all we have to do is just add 75, and now it's 18.75%. The other thing that he wanted us to do is change the tax to 8.75. So we're just going to type 875 there. So the next thing that we have to do is go ahead and change in the output, and we have to say the tax is not 7% anymore, it's 8.75. And the tip isn't 18% anymore, it's 18.75. Let's save this and run it. How much was your meal? $100. The tax of 8.75% is $8.75. The tip of 18.75% is $18.75. And then we have our total. So now this works correctly. If you're in my class, this is exactly how we're supposed to write this program. Number 9 says, write a program that converts Celsius temperature to Fahrenheit temperatures. The formula is as follows. Fahrenheit equals 5/9 Celsius plus 32 degrees. The program should ask the user to enter temperature in Celsius and then display the temperature converted to Fahrenheit. So the first thing that we want to do is make a variable called Celsius, in which we ask the user what is the temperature in Celsius. And the next thing that we want to do is make a variable called Fahrenheit, or I just named it Fair for short. And we're going to make it equal to 5/9 of whatever the user input for Celsius, as the formula dictates. And then we're going to add 32 to it. So now that we have this temperature converted from Celsius to Fahrenheit, all we need to do is display it. So we have our extra print statement, and then we have in Fahrenheit that equals to, and then we add our Fahrenheit, and then we're going to format it in the same way. So let's save it and run it and see how this turns out. What is the temperature in Celsius? Let's say 100. In Fahrenheit, that equals to 87.56. So exercise number 10 is called Ingredient Adjuster, and it says a cookie recipe calls for the following ingredients: 1.5 cups of sugar, 1 cup of butter, and 2.75 cups of flour. The recipe produces 48 cookies with this amount of ingredients. Write a program that asks the user how many cookies he or she wants to make, and then displays the number of cups of each ingredient needed for the specific number of cookies. First thing that we're going to do is make a few variables. A constant variable of cookies, and we're going to make this equal to 48 because our normal batch makes 48 cookies. And then we're going to have sugar of 1.5, butter of 1, and flour of 2.75, because that's how much of these ingredients is necessary to produce this many cookies. The next thing that we're going to do is ask the user how many cookies they want to make, and we're going to make this and we're going to put this in a variable called total cookies. Then we're going to make another variable called cookie ratio, which just takes the total amount of cookies that we're actually going to make, and we're going to divide it by the number of cookies that the recipe makes standard. And that's going to give us this cookie ratio. So the next thing that we want to do is take all the ingredients here and multiply these by this cookie ratio. So say how many cookies you want to make. Let's say you want to make 24 cookies. Now we know right off the bat 24 is half of 48. But if we plug this into cookie ratio of total cookies that we want to make is 24 divided by this cookies here, which is 48, what we actually get is half. So half is this cookie ratio. We're going to multiply all these ingredients times half, and now you kind of see the logic of what I'm doing here. So after we get all these ingredients to the right ratio that we need, all we have to do is print it out to the user. So you will need the following ingredients: sugar is going to display the amount of sugar, and then followed by cups of sugar, butter, cups of butter, flour, cups of butter, or flour, cups of flour. So let's save this and run it, make sure it runs how we expect it to. How many cookies will we make? Let's just say 24. And we will need the following ingredients: 0.75 cups of sugar, half a cup of butter, and 0.38 cups of flour. And this is exactly half of these ingredients, so you know we did the logic and the calculations right. So this program is completed. Now we can move on to the next one. So exercise number 11 is called male and female percentage. It says write a program that asks the user for the number of males and the number of females registered in the class. The program should display the percentage of males and females in the class. And it gives us this hint. It says, suppose there are 8 males and 20 females in the class. There are 20 students total. The percentage of males can be calculated as 8 divided by 20 equals 0.04 or 40%. The percentage of females can be calculated as 12 divided by 20 equals 0.6 or 60%. So that's about what we should expect. That's the logic that we're going to follow here. The first thing that we're going to do is ask how many males and how many females are in the group, and we're going to save this to variables male, how many males are registered, and female, how many females are registered. And previously we've been casting these as a float, but we're going to cast these as an integer, because you're not going to have a fraction of a student in the class, right? That doesn't make any sense. And now we can actually do some processing. We can make a variable called total, which is going to be males plus female, and we can make a variable called percent male, which is going to be males divided by the total, just how they did here, and percent female, which is females divided by total. Now the last thing that we have to do is actually give this information back to the user, and when we do, we're actually going to want to format this in a particular way. So this is just going to say no remainder, and it's going to leave a percent symbol in there. So let's save this and run it. How many males are registered? What did the example say? 8 and 12. Let's do that. 8 males and 12 females. So there's total students, 20 students, percent males, there's 40%, and percent females, there's 60%. And that's exactly how the example was given us. So we did everything correct, and let's move on to the last program. So number 12 is called stock transaction program. The description is a little bit longer, but the program isn't overly complex. It says, last month Joe purchased some stock. Here are the details of the purchase. He purchased 2,000 shares. He purchased them at $40 a share, and he paid his stockbroker a commission of 3% on all those stocks. It says 2 weeks later he sold those stocks, and he sold all 2,000 of them. He sold them for $42.75 a share, and again he paid his stockbroker a 3% commission. So we just want to write a program that displays how much he paid for the stock originally, the amount of commission that he paid when he bought the stocks, the amount that he sold the stocks for, and the amount of commission that he paid when he sold the stocks. And finally, we just want to display the amount that's left over. And this is going to say whether or not he actually made money. So the first thing that we're actually going to do is make some variables. So the commission is 3%, and that's when he's either buying or selling. So this is just going to be a constant variable. Shares, whether he bought or sold, are 2,000, so that's also a constant variable. The purchase price, there's only one of those, that's going to be constant. And the sale price, there's only one of those, so that's going to be constant. Now we're going to want to do a little bit of math. We're going to make a variable called total purchase price, and this is going to be equal to the amount of shares that he bought, which is 2,000, times the purchase price, which is 40. And we're also going to make a variable called total sale price, which is the amount of shares, again 2,000, times the sale price here. So now we want to make a variable called purchase commission, and that's just going to be equal to the total purchase price times the rate of commission. And then sale commission is going to be the same thing, but it's the total sale price times the commission. And then the total commission is just going to be the combination of the sale commission plus the purchase commission. Now we're going to make two more variables here, the total after commission, which is the total sale price minus the total commission, and the total profit, which is going to be the total after commission here, minus the actual total purchase price. And once we have all this information, we can display it back to the user. We can tell them the purchase amount, and that's going to be the total purchase price, the purchase commission, which we have here, the sale amount, which is the total sale price, the sale commission, and the total profit. Now let's go ahead and save this and run it, make sure it runs correctly. And so this one doesn't ask the user for any input, it just displays the information. It says the purchase price is $80,000, the purchase commission, the sale amount, the sale commission, and the total profit. So Joe actually made some profit here, good for him. But you know who really won is this stockbroker. Alright, well thank you guys so much for watching. Be sure to subscribe, and if you like this video, give it a thumbs up. And if you're into these tutorials, I'm definitely going to be putting these out for the rest of the semester. Alright, take care. We'll see you guys next week.